Chapter 4, Section 2, Integral Exponents. What this means is we're going to deal with exponents, as you've seen before, with whole numbers, but we're going to allow for the first time exponents to actually be negative. So don't be scared. Remember, an integer, okay, it's a whole number, meaning no decimal, but it could be positive or negative. All right. So I have here a little list, a little chart, and I'm actually going to put one more here at the top, just for fun. I'm going to put 2 to the power of 3 equals. Okay. Well, 2 cubed, that's just 8. But really, where did that come from? That just came from this. 2 times 2 times 2. Okay, that's nothing new. So let's go down. 2 squared, well, that is 4. But where did that come from? That's just 2 times 2. So notice how as I'm going down this side, the exponent is just decreasing by 1. So 2 to the 1 is just 2. And that just came from, well, 2. Okay. I only have one of them. What is 2 to the power of 0? Well, let's just keep this pattern going. As the exponent goes down by 1, this number is just being divided by 2 every time. So when this 2 cubed became a 2 squared, I just divided 8 by 2 to give me 4. And then when this decreased from a 2 to a 1, I just took my answer and divided it by 2 again. So I'm going to keep that going. So this would just be 1. And it turns out that anything to the power of 0 is 1, except for one example, 0 to the 0. Okay? We're not going to worry about that right now. Okay, well, 1 is just 1. There's nothing I can do. Well, keeping this pattern going allows us to work out what 2 to the negative 1 would be, or 2 to the negative 2. So now exponents are negative, and, well, you might want to freak out, but there's no need. We're just going to keep this pattern going. Okay? So if every time I go down, I divide by 2, 1 divided by 2 is just a half. Okay? Well, that's only written once, so that's just a half. Okay? And let's keep going. So this exponent decreased by 1 more time, so therefore I just divide by 2 again, which is a quarter. But that can be written as 1 over 2 times 2. Okay? So you can compare that now, this one to this one. Okay? So 2 to the power of 2 is 2 times 2. 2 to the power of negative 2 is 1 over 2 times 2. Let's do one more. I started with 2 to the 3, so let's do 2 to the power of negative 3. What does that mean? Okay, again, I just decreased my exponent by 1, therefore this just gets divided by 2. That's an eighth. But remember, 8 is just 2 times 2 times 2. Okay. So I'm just going to change color here. So this matches or corresponds with this one. So 2 times 2 times 2 versus 1 over 2 times 2 times 2. So hopefully you can see a bit of a pattern. If you can't, well, that's what more examples are for. All right, so 5 squared is 25, which came from 5 times 5. 5 to the 1, okay? As I go down, okay, the exponent is just decreasing by 1. So what that means is with my answer, I just divide by 5 every time. So this is going to be 5. Well, I can't really write that as 5 times itself. It's just 5. 5 to the 0. Well, the 0 is special. Anything to the power of 0, except for 0, is 1. Now we're getting into the negatives. Uh-oh. But no worries. Just keep dividing by 5. So 1 divided by 5 is 1 divided by 5, or 1/5. There's nothing to repeat on this one. 5 to the negative 2. Well, I'm just dividing by 5. But really, that comes from this. And there we go. So I'm just going to generalize this result a little bit. So x to the power of n. So x is just some number, and n is, again, some number. But I'm going to assume that it's some positive integer. So maybe it's 2, 3, 4, 5, I don't know. What it means is you're just multiplying by x every time. So every time n increases by 1, you multiply by x one more time. Okay. So really what this means is x times x times x times x times dot 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 times x, however many times. Okay. There are n of them. Okay. That's what it means. What if my exponent is negative? So x to the power of negative n. Well, instead of multiplying, I'm just dividing. So negative exponents do not imply negative numbers, they imply division. So divide. All right. So really what this means is, how do I write this? Do it like this. So x times x times x times dot 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 times x. And again, there are n of them. But that can be written like this. There we go. So x to the power of negative n is equal to 1 divided by x to the positive n. So let's use this result in a few examples. All right, evaluating powers. What is 8 to the power of negative 3? Okay, well, it doesn't really make sense to think of it like, how do you multiply 8 by itself negative 3 times? We think of it in terms of division. So this is 1 over 8 to the positive 3. Okay? So this just moves to the denominator, and then the sign goes from negative to positive. Okay, 8 cubed. So 8 times 8 times 8 is 512. Okay, so 8 to the power of negative 3 is a fraction. It's 1 over 512. Next, 3 to the power of negative 4 times 3 to the power of 7. Well, here we get to apply some of our exponent rules that you would have learned in previous math courses. So whenever you're multiplying two powers and the bases are the same, hopefully you remember what you can do with the exponents. That is, you add them. So this becomes 3 to the power of negative 4 plus 7. Okay? So all of our exponent rules that we learned when we were younger still apply. It doesn't matter whether the exponents are positive or negative. So that's a relief. We don't have to learn a bunch of new rules. So negative 4 plus 7 is 3. And I can evaluate that easily. 3 cubed is 27. There. Wasn't so bad. Next, 2 to the power of 5 to the power of negative 6. So it's a little bit different than this one. When I have a power that's being raised again, you would have seen this before, we don't add the exponents, we multiply them. So really this is 2 to the power of 5 times negative 6, okay, which is 2 to the power of negative 30. Okay? So that is 1 divided by 2 to the power of 30. Now, 2 to the power of 30, I have no intention on working that out. I mean, you can put it in your calculator and you get, oh gosh, 1,073,741,824. Hey, I'm not going to write that out. Forget it. This is good enough. Last one. 7 to the power of negative 2 divided by 7 to the power of 3. Okay, so I am dividing a power by another power, and notice that the bases are the same. It's just like this one, when we were multiplying two powers together of the same base, only we're dividing. Well, to work out this example, we added the exponents. So, for this, we subtract. So 7 to the power of negative 2 divided by 7 cubed is just 7 to the power of negative 2 minus 3. Well, negative 2 take away 3 is negative 5. Okay. So now I can write that as 1 divided by 7 to the power of positive 5. If I work that out, it's not a particularly nice number, but oh well. That is 1 over 16,807. That's what my calculator gives me. That's a pretty small number. Positive, but it is small. So I'm just going to box these. This is the only one I didn't bother evaluating completely because the number was too ridiculous. Okay. So hopefully this example will make you appreciate exponents a little bit more, because once the exponent starts to get large, the number just gets too crazy. Simplifying powers, positive exponents only. So these examples down here, the base is x, which is just a number. So we'll leave it as x. We don't know what it is. All we're going to do is we're going to simplify these as best we can, and we're going to make sure that our answer contains no negative exponents. So we want positive exponents only. So I have x to the power of negative 3. Well, I can write that as 1 divided by x to the positive 3. Okay? There's nothing more I can do with that. There's no numbers to work out. Everything is positive, exponent-wise. I'm good to go. Next, x to the negative 2 times x to the negative 10. So when you multiply powers of the same base, you add the exponents. So this is x to the negative 2 plus negative 10. Okay? So negative 2 plus negative 10, that's the same as negative 2 minus 10. So I get x to the minus 12. And I can rewrite that as x to the positive 12. Down there. And I'll box this. Next, x to the negative 2 cubed. Well, this is when we multiply the exponents. So this is x to the negative 2 times 3. So that's x to the negative 6. And now I can make all exponents positive just by putting this in the denominator. And there we go. Next, division of powers. The bases are the same, so I subtract the exponents. So this is x to the negative 5 minus 4. So this gives me x to the power of negative 9, which I can rewrite as 1 over x to the positive 9. Done.